The same thing, the conceptually will come is the vorticity vector. The vorticity concept will give the rotationality of the So that is nothing but better to write it the curl of V is equal to C. Curl of V. Curl operation, if you remember the curl operation, we are doing in this way. Vector, just you recap of your vector chapter in the mathematics engineering. I, J, Z, del, del X, del, del Y, del, del. Because this vector is already, if you remember, del operator. And V is the U. V. This is the, sorry, it's not 0. Is 0 for the vorticity vector. Sorry, the vorticity vector. Whenever it is a null vector, then the flow is irrotational. We are just first interested to finding out this thing. So I, if the vorticity vector I direction, so I, so dw dy minus dv. This is the x plus j du dz minus dw by x. Plus dv dx minus du dy. As the vorticity vector. You see one thing, the previous case, we are considering one part. We are telling that omega z is a capital omega, it's a small. Omega z is equal to half del v del x, angular velocity. So it's the angular velocity about the z-axis. It is the vorticity vector about z-axis. Vorticity about z-axis. So 2 omega if you do it. That is nothing but. So vorticity vector is the double of the omega. Vorticity vector is the double of the angular velocity. So vorticity about z-axis is the double of angular velocity. So this value that is nothing but 2 omega x about angular velocity about x-axis, angular velocity about y-axis, angular velocity about z-axis. You can write it. So 2 into angular velocity vector, 2 into angular velocity vector. That is the way or the form to write it down in this cases. That is the way, the form you can write it down in that. There is no doubt about it. You can simply one thing, if you write it down in the indices form, what is the thing is the most important, you say u is equal to u1, v is equal to u2, and w is equal to u3. Why I am invoking the because it will gives you the better idea or generalization of these cases. It will gives you the better idea or generalization in these cases. So here, if you replace only this part, so So vorticity vector about x-axis, or you can write it down the plane. So which plane it is? 2 by 3. Because it's a YZ plane. YZ plane, or whatever it is written vector, is the perpendicular to the plane. So x vector is perpendicular to the YZ plane. So y for 2, z for omega 2. So this is coming as u3 by x2 minus. Okay. That is the way to write it down. So hence, you can say here, same way, vorticity vector here, y plane. Y plane means zx. Y plane means zx. So u1 x3 minus u3 7. And the third one, third portion, vorticity vector about xy plane. Xy plane, u2 x1 minus u1. You see the second term is come first and first term is coming second. So in that way, if you write ij is equal to uj xi minus uy, that is the position. First is coming the second part. Here also first 1 is coming. Here first 3 is coming. Here first 2 is coming. That is the way to think about it. It's an easy form. Anything you can going by this virtue. So that is the vorticity concept. If the flow is irrotational flow. Now concept is if the flow is irrotational flow. So irrotational flow means del x is equal to 0, del y, each term will be equal to 0, del y is equal to 0, del v. Each and every factor will be 0. So this term, if it is 0, only for irrotational flow. So irrotational flow definition is this. So if I recap, thing is easy understanding. If the flow is incompressible, recapping just, incompressible flow, divergent of velocity vector, sorry, the divergent, and irrotational flow, curl of velocity vector is, that is the difference between irrotation and incompressible. That is the difference. But if vorticity vector is existing, that means flow is definitely a rotational. If the vorticity vector is existing, we can say the flow is a rotational flow. If vorticity vector exists, is a rotational flow. If not exist, so vorticity vector is 0. That means curl of velocity vector is 0. So one more concept I am going to give you, that is the circulation concept. Circulation concept. So how it is related to the vorticity vector, we'll see it. So in the circulation concept, over the contour, you choose one contour of the fluid. You're choosing one contour of the contour. here, one small area is a length scale you are taking. Contour length, small length you are taking dl. So contour integral of the v dot dl will gives you the circulation. The circulation is the v dot dl, velocity vector into dl vector. This is the length element over the contour integration. Contour integration v dot dl will gives you the contour integration. Mostly is the mathematical. It also gives the rotationality of the flow. How it is a sense. If you gives the Stokes theorem, if you gives the change here, like the Gauss divergence theorem, if you invoke the Stokes theorem here, the contour integral can be converted into the curl of the velocity vector over the area. What is the surface? Now, if you it's the line integral is converted into the surface integral. Line integral is converted into surface integral. So we are just one contour integral is converted into the surface integral. This is nothing but the vorticity vector. So it seems that the circulation is can be written as the vorticity vector per unit area. Circulation per unit area will gives you the vorticity vector. Or if you multiply the per unit area, what does it mean? Here if you choose one area, a small area, if you choose it here, and the area is a vector quantity, so here the vector is the perpendicular. So n dot d. The area vector is the dA vector is the n dot d. Unit vector into magnitude. This will gives you here in this. So that is the concept of the circulation. It is depends on the sense of rotation. If circulation is existing means, so vorticity vector existing means circulation will also be existing. For irrotational flow, the circulation is also zero. For irrotational flow, because the vorticity vector is itself is zero. So circulation is a actually better to write it line integral or contour integral of v dot dl. What is the sense of it? It sense the rotationality. Rotationality to sense the vorticity vector in multiplied by area. You're considering the area also. So that's in the case. Circulation, one problem will be just taking one problem here. You take one flow is given to you. That is a U is given AY plus B and V is given as the balance. Same question we will see here. Just A is given as a 10. So one curve circulation, you are asked about a curve bounded by y is equal to 0, x is equal to 1, y is equal to 1, x is equal to 0. One curve, how it is looks like. First we draw this diagram. XY. So y is equal to 0. So y is equal to 0 means this line, x-axis. Y is equal to x is equal to 1. X is equal to 1 means x at 1. So everywhere there is an x at 1. Everywhere. Y is equal to 1. In this line, everywhere there is a x is equal to 1. And x is equal to 0 is 0. So this is the curve I'm choosing. So this is a line, sorry, this is a line. So to solve this kind of a circulation problem, it is bounded, the area is bounded by this area. U has been given to you. U has been given to you is the AY plus. And V has been given to you minus X. It's a two-dimensional. It's a two-dimensional. If you go for the vorticity vector, you can go in this way, vorticity vector directly. I, J, K, because vorticity is the curl of velocity vector. It's a curl of velocity vector. So no z component. So del x of del x, del y, del z. U is given as a AY plus B. B is given minus X is equal to 0. Nothing is given. So if you see I component, if it's the I component, I into 0 minus 0, because it's a X only, it's not a variable of Z. So it's a I dot into 0. Yes. J dot. It's better to write in this way, J. D dz of this part. This part is 0. And d dx of 0. So already it is. Because here no z variable is there. So only k component will be. K component d dx of minus x plus d dy of ay. So it is written as the minus a. D dx of minus x will gives you minus a. Minus of d dy of ay plus b. So again minus a. So minus 2a into k. That is the vorticity vector. A is already given as the 10 per second. So minus 20. So minus 20. So vorticity vector we are getting it here. Minus 20k by this calculation. The simple curl operation we are doing it here. So there is no change of the vorticity vector. Now the change will comes in this way. So vorticity vector minus 20k. Now again you draw the same thing. Along x is along y. And circulation part is in this. Is the y is equal to 0 line. Is the x is equal to 1. X is equal to 0 line. Is the y is equal to 1. So what is the sense of rotation? First, the thing is the sense of the rotation, how it is important. First, we are considering y is equal to 0. So in this, y is equal to 0. Next, x is equal to 1. Curve is bounded by this. Y is equal to 0. Then x is equal to 1. Then y is equal to 1. Then x is equal to 0. So rotation is in this direction. So rotation is the anti-clockwise direction. So as it is the anti-clockwise, so it will come positive z axis. As it is the anti-clockwise rotation, if you keep your right hand in this way, anti-clockwise rotation, you will see the positive direction. So this vector quantity, the area vector, area should be the positive direction. So hence it is be n dot dA, n dot dA. dA, n dot dA is already nothing, is the total area of the rectangle area. N dot A, you can write it down because the A is simply, you can see 1 into 1. This is 1, this is also 1. Y is equal to 1, x is equal to 1. So A is 1. So the simple the circulation about the curve, vorticity vector into area. Vorticity vector is 20k, and this is the positive z axis, means k into 1. So minus 20 will be the answer. Circulation is the minus 20 in meters square per second. The circulation minus 20 is the answer. This is the way, because the sense of the rotation here, the sense of the rotation is anti-clockwise. So anti-clockwise, if you see your right hand in this way, you will get a right hand screw rule. If you follow, you will see the positive z axis, it will be comes. The second problem, the curve is same curve, just first y is equal to 0. The same curve I just of this thing. The second problem, nothing in here, same thing. Just it is changing the y is equal to 0 first, then x is equal to 0, then y is equal to 1. Then sense of rotation, y is equal to 0, x is equal to 0 in this clockwise direction. So clockwise direction here, vorticity vector is the same, 20 minus 20. The same calculation you can do it. The sense is the different, is the as it is the opposite direction. So here the circulation will comes into the vorticity vector. Vorticity vector minus k, because negative z axis. If you clockwise rotation, if you put it in this way, it is the negative z axis. So minus k. So minus k, it will comes minus 20 k into minus. So it will gives you 20 meter cube per second. That is the difference in here. These two questions. These are the same figure, but sense of the rotation, as the sense of the rotation is the different. So whenever you convert it into the area integral, so it is area direction will be the change. The area direction only here the changing. Area magnitude is the same for the both cases, that is 1. Direction, eta vector is changing in the both cases. And eta vector is depends on the rotation, which way, the curve bounded by which curves. That is the way to finding out this kind of the problem.